Welcome. My name is Tim Stewart from Visual Decisions. We're here today to talk about cybersecurity in manufacturing, protecting what IT can't see. And with me, I have a couple of experts from Sandalwood Engineering and Ergonomics, Drew Teed and Tyler Moore. Why don't you guys give a quick introduction to yourselves and to Sandalwood, and then we'll get started.
Yeah, thanks, Tim. My name's Andrew Teed. I am a cybersecurity team lead with Sandalwood, and I've got kind of, as far as cybersecurity goes, I've got a little bit of experience and background with kind of program development, policy development, that sort of thing, as well as R&D of solutions and tools. And right now, my current role is kind of strictly implementation of cybersecurity. So I work in a manufacturing environment, and my job is to make sure all the cybersecurity controls are in place, get them in place, get over any technical hurdles along the way, and then monitor and ensure adoption of those controls and make sure they're always active. So it's kind of what I do right now. Tyler?
I am Tyler Moore. I am also a cybersecurity engineer. Pretty much all of the above what Drew said. And my background is in network design and security. And I am based in the Chicago area.
Excellent. All right. As I said, we're going to be talking about cybersecurity in manufacturing and protecting what IT can't see. For myself, I'm much more of a heavy on the manufacturing side, not nearly as much on the cybersecurity side. But I've definitely seen the importance of this, walking through the plants late at night and coming in on second or third shift and seeing people watching ESPN on their HMI at the machine.
Yeah.
And just knowing that environment is not locked down properly.
Exactly.
So some of the topics that we'll cover today are, IT and OT limitations and differences, some of that historical divide between the IT and the OT groups, essential cybersecurity foundational frameworks. What are those basics that we need to look at? How and why to lock down the production environment, visibility and monitoring, and then vendor and equipment controls. All right, so let's get started here. Let's talk about some of those differences between, that traditional breakdown between IT and OT.
Yeah, and one thing that really demonstrates that difference is the CIA model. So when I came through school, network security and going through that program, it was always CIA. C for confidentiality, I for data integrity, and then A for availability. So that in that order, that's the priorities of the IT environment. So in the OT environment, on the plant floor, it's reversed. So it's A for availability, I for data integrity, and then C for confidentiality. So availability is key. Downtime is lost money. Whereas in an IT environment, if if someone can't access their email or get to some files, it's not as big of a deal. They just have to wait a little while. And there's also like general management differences between the environments as well. So in the traditional like IT world, the IT skills are needed. Like especially in the realm of networking. And typically this skill set is lacking in the OT world. But on the plant floor in the engineering world, that those IT skills are lacking there for sure. And you really need those production or those engineering skills to understand the processes on the plant floor and to prioritize uptime. Because like I said, downtime is a big no-no.
Yep. So cybersecurity takes both, right? Is what
Yeah.
you're saying. It
Needs
takes
someone to bridge that gap
yeah,
between those two worlds.
Yep. It's not that IT isn't relevant. It's not that engineering isn't relevant. It's that they're both relevant, as
Exactly.
well as other players as well. But it's kind of the simplest way to break it down is the IT OT divide, and you need both people thinking about cybersecurity in order to get it done in that.
Exactly.
Yeah. I mean, I've worked with a lot of different IT departments over the years, and I've come across people in IT that have a good handle on the different things on the shop floor, but not a huge number of them.
Yeah, it's not common.
Yeah.
And
it's
mostly it's interest based, right? Like if they seem to have like a real vested interest, like a personal interest in kind of manufacturing, they'll come out there and apply their skills and share their skills and that kind of thing. So, but that's not usually like a fostered type situation, right? It's just that's personally driven.
Yeah, it's not the organizational level.
Yep.
Right.
So basically what that leads to is what we see as kind of patchwork knowledge of things and different pieces being put into place, and they're all good for sure, but you need the whole puzzle, right?
Exactly.
And going back to the CIA and AIC, those are all priorities for both IT and for OT, right? It's just a matter of what comes first out of those.
Right. Exactly.
So, if you're in HR and you're looking at, the ERP system and so forth, the most important thing, even legally and so forth, is to protect that confidentiality. You don't want salaries and personal information of people getting out and so forth. And so from that business system perspective, you're looking at it that way. But for machine data, if I'm just, pulling a stream of temperatures off of a machine, I don't have that same level of need around that confidentiality. Certainly from a business privacy perspective, you don't want that getting out to competitors and things like that.
Yeah.
But that availability of that machine and so forth, if you're looking at like controllers and so forth, that has to be something that doesn't shut the machine down because you're
Yeah.
Exactly. Yeah. Perfect.
It's like Tyler was saying, it's if you lost access to your emails or you lost access to a certain HR database of personnel files, the 2 hours probably isn't going to kill you. But if I lost access to my database that a machine is pumping up, quality data to, that after it checks parts and now it can't talk to that database, like now the whole plant's stopped, right? It's all backed up. So it's a completely different beast. It's all, you're dealing with the same kind of things. Like I said, database and database, both sides. But that access is critical in the one area versus the other.
For sure.
So just kind of expanding on the limitations and differences between the two. I think we kind of already covered it's you don't have the total knowledge within one group generally in order to enact your cybersecurity. So you kind of need to figure out a way to bridge that gap. It's either bringing people with specialized knowledge or you develop kind of your organizational framework to ensure that that knowledge is being shared between the necessary groups. So you just don't have that specific tool set and knowledge in place in the production environment. Another big difference is the usage of legacy systems, and then proprietary systems are kind of in the same vein of
my Windows 95 machine out on the shop floor is not a good thing.
Yeah, exactly.
You joke,
right?
but
It's-
2 weeks ago, I found one on the plant floor.
Yep.
I see them not often anymore, but I still see them out there.
Yeah. There's DOS out there. There's all kinds of old, ancient stuff, and that's unheard of in IT, right? IT's replacing your stuff really when it becomes relevant to replace it. Like you're not using a laptop from 20 years ago, right? It's from a few years ago. That kind of thing. Same thing in their data centers. They're not switches from 50 years ago. They're pretty new, so to speak. Relatively speaking, they're new. But in the OT world, if it works, it works. So you might have equipment out there that's 50 years old, like legitimately, and it's because it does what it's supposed to do, and there's no reason to make it any better, right? So it's there, and you maintain it, you keep it running as well as you can. So what's that give you for cybersecurity? You still got to protect that stuff, right? And in my mind, the fact that it's 50 years old just speaks to the criticality of the system. So your protection of it is even more. There's more need for the protection. It's not that it's just like, oh, it's so old nothing can happen to it. No, it definitely things can happen to those machines as well. They are control systems. They send and receive and process signals. They're computers, even if you don't think they are, or you don't think of it as a computer like your laptop. They do things, right? So you still got to protect them. And the fact they're old just means they're that much more valuable. So if you're not dealing with all this stuff, what you get is an unmanaged environment. You get an unprotected environment. It's pretty accurate to think of it as patchwork. It's, you got people doing what they think is right in certain areas, but they don't even think about different areas. So a patchwork environment is, better than nothing, but it's not great.
Yeah, so, in the IT environment, you find a lot more similar hardware, spread across. Everyone at their desk might have the same desktop, but out on the plant floor, you have those Windows 95 computers with the Y2K compliance sticker still on it, and you have everything from that all the way up to Windows 11 and everything in between. So it's definitely a different set of needs.
Yep.
Yeah.
Cool.
So, what are really the foundational pieces to a cybersecurity program?
Yeah. So, your first step, and it sounds basic, but once you step into it, it gets very complicated very quickly. But your first step is having an actual framework. If you have a manufacturing environment and you don't have published cybersecurity policies, that's a sure sign you don't have the framework that you should have to start policing this kind of stuff and ensuring your cybersecurity. So the good news is that a lot of that stuff is more or less developed for you from, specifically government agencies. In America, we do NIST. In the European Union, it's more so the ISA frameworks. But there's already developed frameworks to at least set your mind in the right spot of like, what do you need to do? What do you need to be considering? And if you look at these different different frameworks that are published, and they're standardized industry, standards, you'll kind of see the same thing in all of them. And those categories within those frameworks are identify, right? That means you need to know what you're trying to protect. You need to protect those things. You need to detect anomalies, intrusions. You need to respond to those. How do you do it? What do you do when those things happen? You need to recover when it all goes bad. You need a recovery strategy. And then you need a governing strategy because, like I said at the start, it's once you step into this, it becomes very complicated. And there's a lot of players involved. There's a lot of different groups involved. And everybody kind of needs to be thinking about this. So you need a way to govern it from a company policy procedure type point of view. And of course, the environments we're working in are generally not monitorable, right? Like remotely. You kind of have to get into the specific production network and, more or less plug in and see what's going on if you want to know what's going on. It's usually you can't monitor everything from the top down. So that just lends more to the governance, right? Is everybody needs to know what is your role in this specific activity, which is cybersecurity, and what do you do and what's required. So that kind of leads to that second point there, which is cross-disciplinary training. Really can't stress enough how much cybersecurity is not on its own. It's not a standalone thing at all. Like you can't just hire a cybersecurity guy and he does it all. It's going to require teamwork, right? The whole organization involvement. And one way I like to illustrate that point is, and people probably don't think of it, is, everyone's got a finance department who will buy off on machinery, right? Like this machinery is good to go for our production. It's, and the finance people are looking at, engineering checked it off. It's all good. The maintenance group checked it off. They know what to do. The operators checked it off. They've been trained on how to use it. The safety people checked off on it. It's safe to be around people in the environment. Cybersecurity should also be like kind of one of those considerations. Like, is it protected before we buy this thing? Like, are we just opening up our entire environment to threats by buying this, right? So finance, that's one where cross-training is necessary, right? The finance people need to consider cybersecurity when they sign off on something, right? And actually pay for it. So that's just like one area to get you thinking about. It's not just IT people. It's not just engineering. It's not just cybersecurity. It's a whole organization, because everybody's affected if something bad happens, right?
Exactly.
Finance people care when they stop making money, right?
Yeah.
So
from them all the way down to the line operator.
Yep.
Yeah, and another piece of a foundational piece to the cybersecurity program is risk-based prioritization of your controls implementation. So we want to focus resources where the impacts to operations, safety, and your critical assets are going to be the most severe. So in order to optimize your resources, you need to understand each asset's impact if it were to be compromised, and then what's the likelihood for that to happen. You also need to understand that the asset's criticality and know what active threats and known exploits are out there as well. These are all published, anywhere from 0-day exploits to ones that have been out there for a while. And it's not only just the PCs that you have to necessarily be concerned about, but also, let's say, like your Ethernet card on your PLC backplane, for example. There's known vulnerabilities with those that I've seen personally. So it's just not your PCs, what you traditionally think, like in the IT world, but in the OT world, you have to think about those things as well.
Yeah, and just the volume of those vulnerabilities, Tyler, right?
Yeah, it can be overwhelming for sure.
Yeah, if like you can subscribe to like Homeland Security in America, their CISA group, like they'll send you all the vulnerabilities that are officially reported and published, and you'll get a flood of them, right? So it's like, what do you do with all those? You can't fix them all, right? Like you'd spend all your time and energy fixing vulnerabilities and things and plugging those holes. So what do? You can't do that.
You go based on risk prioritization.
Exactly. So what's that even mean? It means you need to, again, back to the framework. You need to be able to triage vulnerabilities as they come in and say, all right, you know what? That one is serious for us. But others are not so serious, and that's because of what Tyler's going to discuss next, which is defense in depth strategies.
Yeah, it's funny. In manufacturing, there's some process called an FMEA, failure mode and effect analysis. And it comes up with a risk priority number where It's a multiplication of the probability of failure, the effect of that failure, and then the probability of detection. And what you're talking about with that risk-based prioritization sounds like the cybersecurity equivalent of that FMEA process.
Yeah, exactly.
Exactly.
And also having like a complete and accurate inventory of all your PCs and devices is key too. Because if you get one of these threats, alert, you may not know what you have out there, what's being affected. So
yeah,
that's
that's a
important.
big thing we haven't touched on, which seems the simplest, but asset inventory is so big, and it's so complicated that it's even people who think they have good asset inventories, even outside of cybersecurity. Here at Sandalwood, we do projects with manufacturers, and they give us a list of things, and like it's barely accurate, right? They may give you a list of 20 and there's really 50, right?
Yeah.
So things like that, where it's even, I can tell you organizations, you're going to think you have a good asset inventory, but you really don't, especially when you start trying to do something technical with it, like do cybersecurity.
Yeah.
It's a lot more complicated than it sounds. And it kind of goes back to what Tyler was saying. It's sure you've got how many PLCs you got. Maybe you can tell me that, but how many different kinds of this kind of Ethernet card do you have? Like how many different kinds of switches do you have in these PLCs? Like all these different little network devices, they all have vulnerabilities and they can all give access to things they shouldn't be, right?
I mean, I've talked to a lot of manufacturers on IoT initiatives and things like that, and very few of them have an up-to-date and complete list on just what PLCs do I have, what vintage are they, what
Yep.
everything.
Firmware, what
Yeah,
software
firmware.
revisions, when's the last time you updated it, firmware wise, kind of thing. Like, yeah, that information is usually lost because it goes back to availability and production. That's what people care about.
Yeah.
It's you need to be making your products, and you're not really too worried about anything beyond that.
Can you hit that last point on defense in depth quickly, Tyler?
Yeah, so the idea of defense in depth is so you have multiple layers of defense and different types of ways to mitigate attacks or threats. It's the idea that if one defense method fails, you still have multiple to back it up. You can kind of think of it as like a castle, like with the moat and then the towers, and then different things working together to create a complete defensive package.
Yeah, I like that visualization. I've got kind of the moat and then the outer wall and then the inner wall, and then I've got the keeping side of there and so forth.
Exactly. Yeah. So if one fails, it's not end of the world. You still have more to back you up. And a lot of times these attacks are attacks of opportunity. And so if you have all of these, defenses, a lot of times, it's not worth it, or they'll pass on, go to eat something easier too.
Yep. And yeah, that's a good point to mention. Is it's when we're talking cybersecurity, we're not exactly strictly talking about somebody who wants to do you harm, right? It's not that Tim Stewart has a grudge and he decides to figure out how to hack into your production system and shut it all down. That's not necessarily the biggest risk, right? Because I mean, how many people are you ticking off like that? Not many, right? The biggest risk is just the things that are sitting out there, and like Tyler said, waiting for an opportunity. It's things are automated, right? Like we're talking digital world. It's not somebody necessarily on a joystick controlling these viruses. They're just sitting there waiting, and they're waiting like, oh, look, I just saw this switch with this configuration profile. I'm in, right? And it goes in. It doesn't even care where it went. It's just like, oh, look, I just showed up in a drinking fountain factory. Great, right? So whatever it is, they're just waiting for you. So you need that defense in depth. And that's what we're going to kind of go into here is just kind of generally talk about all kinds of different things you can do. I think Tyler's going to kick us off with, how do we even patch things?
Yeah, so patching and vulnerability management is a core piece of the OT cybersecurity program. It's so important because installing patches is a key way to address vulnerabilities on the PCs that are located on the plant floor. I know personally that I do a lot of patch management and installation. However, the OT environment presents its own challenges. A lot of times for these patches to be installed, the PCs need to be taken offline in order to implement those patches. And not a big deal in the IT world. You can just tell someone like, hey, your PC's getting a new patch, go grab a coffee. By the time you get back, it'll be done. In the OT world, a lot of these lines are running 24/7. So finding that downtime to do that is a big challenge that I know that I face and Drew probably faces as well.
And that just goes right back to the risk management you were saying, or risk-based approach, right? Is you can't do every patch. Like we all know Windows patches are coming every week, right?
Yep.
Like you're not doing that in your OT space. You're not going down every Wednesday afternoon just to put some Windows patches on 300 devices. So it's what's important to you, right? And then you have to take into account your defense in depth. It's not necessarily, a lot of these vulnerabilities may require direct person involvement, right? If someone can type away on the keyboard, they can exploit that vulnerability, and then it's a very bad vulnerability, right? It's a 0 day, it's whatever. But are you going to let somebody just come in and type away at the keyboard? Hopefully not, right? So, or if there's someone random was doing that, hopefully you guys would realize, right? So defense in depth, and then deciding what patches do you need and where, right?
Yeah, and another challenge too with implementing patches on the plant floor is that a lot of times these patches, you have to test these patches, because I've had it before where I've installed a patch and then on multiple PCs, and then on one, which is a vision system, it required connections to a camera. I installed the patch and it completely broke it. Good thing that we always take backups before we do any work, so we're able to recover. But that just goes to show that how different installing patches on a OT PC is versus an IT. It's the downtime. It all goes back to the availability.
Yep.
Right.
And then, do you really need it, right? Because what are those systems doing? They're doing production, right? That's your priority. So it's, it just becomes much more complicated. This kind of goes into, I think I was kind of mentioning it, just random people showing up and typing away. Vendor visitor management in your facilities. I see it all the time that it's, we brought in an engineer from such and such vendor to work on that specific equipment from that vendor, something up with it. We brought him in to work on it. And what I see all the time is that engineer just walks right in, plugs his laptop in, starts doing whatever he wants to do
all the time.
And that's fine, right? Because what are we doing? We're prioritizing availability.
Right.
So we're just trying to get it up as quick as possible. However, that guy could have just exposed your whole environment to a nightmare, right? And that's something you also need to consider is making sure that the people you work with, I wouldn't call it so much visitors, but your vendors, the people you're buying equipment from, need to understand what are your cybersecurity requirements on the equipment, right? Because when you buy it, you're buying it with a specific validated function to it. And part of that validated function should be that someone's not going to come in with a virus or a malware and mess it all up, right? Just to say that very generally, mess it all up. So you need that management of the not only the equipment you're buying from people and installing into your facilities, but also like the people you're bringing in after the fact to help you do maintenance and things like that and upgrades.
Yeah, you made a good point about the, everything in the OT environment is about availability. So a lot of times they may cut corners or measures, to maintain that availability, but you also let in possibly worse things without knowing it.
Yep.
A lot of the things that we're talking about here are, kind of little things, just, training the employees to recognize the threat. Some of the vendor management as you're having people on the site and so forth. Talk to me about the network segmentation and, having that physical or VLAN kind of separated and walled off from some of the other systems in the company.
Yeah, so like the things here on this slide, I would call like basics, right? Like this is stuff you should be doing, no matter what your situation or your production goals are. These are the types of things you should be doing, like as a baseline. And network segmentation is kind of your traditional way of ensuring cybersecurity. When I work with systems that have been there for 10, 20 years, that is the only cybersecurity, is that these 5 machines over here, they can't talk to the 5 machines over there. They just can't, right? Mm-hmm. It's walled off from a network perspective, and maybe that's physical, like the Ethernet cables aren't going to reach there, right? Maybe you do it that way, or you can, nowadays you can do VLANs and you can virtually do that Ethernet segregation like that. And that's kind of your traditional way of doing things. In general, I would say OT environments are set up with that in mind. It's usually not all interconnected. Mm-hmm. And that kind of gives us our biggest problem in cybersecurity, which is like, how do you even protect everything when it's all separated, right? But the future goal, which is kind of this slide, is maximum visibility, maximum monitoring, right? And it completely goes against that historical strategy of segmenting everything. Now you want it. You kind of want it all. If you can, you want it all to be connected so you can watch every little thing. And nowadays you've got these, what I'll call newfangled technologies that like really allow you to desegregate that network and have it all accessible all the time for whatever you want it for. And there's a big one that probably most people have heard of is like software-defined networks. These are basically, call them smart switches. And they will kind of tailor your network automatically, sort of, or you can control it. But basically, you can open up network paths on the fly, close them down. You can monitor whatever paths you have and quickly, digitally close them down, automatically close them down, kind of thing. So you get much more high-level control of your network, or detailed control of your network, with those kind of things involved. And that allows you to open up your networks, desegregate them, because now it's like, all right, well, if this one who's not supposed to be talking to this one all of a sudden starts trying to talk to the other line, our SDN systems will see that and say, no, and we'll shut that down, right? So even though it's open, it won't be allowed, kind of thing. So that's functions you can do with your networks nowadays. Another one is deep packet inspection, which is like my favorite, because it's like the most detailed thing you can do. Yeah. All data being passed anywhere, from any device to anywhere. It doesn't matter, OT, IT, any device is sending its data in a packet. and that packet's got headers, footers, contents, metadata, things like that. And if you can see everything, you can monitor those packets. And again, it goes back to, we've designed our environment for one thing. We know what it's supposed to do. We know technically, I mean, we don't know right now, but technically I know exactly the type of data that should be going from a switch to a photo sensor, right? I know exactly the kind of data that should be going there. It shouldn't ever change, right? And that's what deep packet inspection allows you to do. And there's all kinds of software and vendors and tools out there that can do it. But that's a very powerful thing that allows you to start setting up active monitoring, active alerting, that kind of stuff in your network. And that includes all your industrial devices too. But it comes with network desegregation, right? So how do you do that is kind of
exactly.
That's our main thing, doing that safely, and then having everyone who needs to be involved aware of what we're doing, why it needs to be there, how do you interact with it for your job, all that.
Well,
we're going a little long.
We went a little bit past our time here, but I do want to get some final thoughts from each of you. Tyler, if you go first, I'll ask you, what are some of the things that you really want people to remember?
One of them I would say is backups. A lot of times people don't think about it, but that's often sometimes the quickest way to recover from an attack. If that PC is compromised or there's ransomware, well, you have a backup of it. You might need to tailor it a little bit to get it running again, but you just wipe it and start new. Having a good backup system is key in my mind. Also, having a complete, like we said, a complete and accurate inventory, so you know what threats, or if there's a new threat that got released or you're notified of, what's out there, what's being affected by it. Otherwise, you're kind of just blind. I would say those are my two.
Okay, Drew.
Yeah. My biggest thing is the framework. I keep talking about frameworks, but nobody knows what to do if it's not officially written down and published. And obviously, before you do that comes a whole lot of inter-organization discussions. If we're going back to that NIST framework I was talking about, you can't just download the thing and publish it and you're good to go. It's not going to work for you. You need to take that as a high level and then develop your own organizationally specific frameworks. And that framework is what allows you to do the cross-disciplinary training. It's what allows you to ensure you get a good asset inventory, like Tyler's talking about. It's the framework. You need requirements, and if you don't have hardcore cybersecurity for manufacturing policies, then it's probably a sure sign you should think about that and do that. And that is where you start. You got to start with a framework and what do we need to accomplish. Then going in with that is the experts in training. You need people who understand both worlds to really, or at least you need someone from each world who's very willing to work together and develop it, right? But there are people out there who have worked in both worlds, is a good point. But the last thing I want to say is that this is all constantly evolving, right? It's insane. You like we said earlier, plug yourself into the vulnerability databases, and it's just I don't even know what to do with that, right? It's just endless. It's oh, that sounds serious, and then 2 hours later, it's oh, well, that sounds serious too. So everything's constantly evolving. Your solutions are evolving, and what's that lead to? It just means you need somebody thinking about it all the time, and you need somebody paying attention. and it's all about that governance, right? So,
Yeah.
So frameworks. I'm all about frameworks. I'm all about rules and regulations. So,
Yeah.
Well, as a manufacturing guy, I would say that it's around the standard work.
Yeah.
And
yep.
in manufacturing, everything is around standard work, and it sounds like that's same thing for cybersecurity.
Yeah. We don't want it to be variable and confusing and mysterious. It needs to be standardized, like you're saying.
Yeah.
And everybody just needs to know what that standard is and go from there.
I mean, for me, my big takeaways are in the infamous words of Donald Rumsfeld, it's the unknown unknowns. As a manufacturing guy, this is a world that I don't know, and that I don't have the bandwidth to educate myself on. And so for me, what my takeaway is that it's really good to have either experts like yourselves in house, or to have experts on call that you can work with. And certainly, I've had a long relationship with Sandalwood. I recommend you guys extremely highly. If anybody in the audience wants to get in contact with them, I think we forgot to put a slide in here with the contact information, but you can reach out to me. I'm Tim at visualdecisions.com. Visualdecisions.com is the website. For Sandalwood, sandalwood.com is the website, and that gives contact information there. Drew and Tyler are both on LinkedIn. You can reach out to them there. And if you guys want to give some quick contact information, you can do that here too.
Our emails are pretty simple. It's your first letter of your first name, and then your last name. So mine is ateed@sandalwood.com.
Okay.
And then
Mine
Tyler.
tmore@sandalwood.com.
So pretty easy to find us, but
Yeah.
the website's the go-to if you need to just ask.
They'll come back to
can't
us.
find us. Yep, you'll find us.
Sounds great.
But yeah, it's been good. It's been great, Tim.
Thank you both.
Thank you, Tim.
Thank you both. If you could stick around for a minute afterwards, that would be great. To the audience, thank you for attending, and we look forward to hearing from you.
Yep.
Cool.
Thank you.
Thanks, everyone.
All right. All right.